Okay, welcome to Module 5.3 for Information Resource Systems Resource Management. We're talking about overall frameworks and infrastructure. And here what we're focused on is the core hardware and the way we put these things together. When we define the overall IT architecture, the intent is to bring order to otherwise chaotic world of information systems by defining a set of guidelines. If we just allowed every IT person to go out and make the decision that they wanted to, you'd have a mess, and I would suspect that many IT departments are exactly like that. What architecture does, it tries to bring things under control and reflects the business strategy, such that we don't want one system that's going to be very difficult to maintain over here and another system that's very difficult to maintain on this other side, and they're in two totally different technologies, which means I have to have twice the staff. When most IT professionals bring in or they advocate certain applications, sometimes they're known as resume builders. They want to basically bring in this application and say, hey, this is great for the organization, and in reality, they're the ones who want to learn it. It may not be best for the organization. So that's why having a third party like architect validate not only the application but the business use is important. Generally, architecture is run or managed by the Chief Technology Officer. However, there is value in having this independent architect. So you might see a group called the Enterprise Architecture Team, which actually has data architects, information architects, solution architects, various different architects so they can work together by going to the business, finding out what's needed, and then understanding the technical ways that this can be done. One of the frameworks that's out there is the Zachman Framework. I'm not going to spend too much time on this, but this was an original model back in, I believe it was in the 90s, where when you're trying to plan for systems, you want to identify the what, which is the data, the function, which is the how, and the where, which is the network. And you had these six different sections of the planner, the owner, the designer, the builder, the subcontractor, and the consumer or the user. And this would be the framework for the design of the system. What this does is, this does have all the basic elements, but it's too rigid. There's been a lot of people who have some issues with the Zachman Framework, and you'll actually see on the blackboard there's a video for the Toga Framework, which is another one, which is an open group architecture framework. This is an example of the enterprise architecture for the Zachman Framework, where you see, for example, list of things important to the business over here. We have a semantic model of the conceptual of what it's supposed to look like. We may have data models, we may have the design, and a data definition. And as we move further along, say for the network, we may have the where, the network where is it going to be, the list of locations, logistics network, distributed systems, system architecture, network architecture. Later on, the second extension of the Zachman Framework actually came, it was the people, the time, and the motivation. So these three columns were added in a little bit later that said, okay, who's going to be doing things? And who needs to be doing things? What does the organization look like? What does the structure look like? You may remember from one of your previous classes, not in this class, but the importance of structure in the organization and how that can impact information systems. The when, we need to understand what are the events that are occurring, because this is, are things going to be linear? Are things going to be distributed? Is there an interdependence or not? And the motivation, ultimately, what are the goals behind doing this? Are we in line with the business plan, or is this something that's just a renegade project? In a service-oriented architecture, and it's a little bit more technical, the functions are services, and they use the concept that each individual system is able to expose certain services so that other systems can interact with them a lot freer. The problem with service-oriented architecture is that when it does so, it has to do so on a transaction base. So what that means is this: we're sending one request with a set of data, either one or a few, at a time, and then we get a response back. So it does require a little bit of understanding of, does the information have to come back? And if it has to come back before I can continue processing, what happens if that FAR service fails and doesn't send it back? Does that mean my transaction ends? Another consideration is how much data can actually be sent this way. It may not be prudent to actually send a large amount of data using a services-oriented architecture. One of the things that you have to consider is whether or not you should just send it through the database layer, where I can send massive amounts of data very, very quickly, and then is there any transformation that needs to occur? So even just exposing the services, this is more getting to atomic level transactions. I want to place an order, I want to find out the status of an order if you're in healthcare, status of a claim, and for those of you who are familiar with healthcare, you might see services around the 837 to send a claim, or the status around 835. 277, 278 EDI documents Again, I can send it, this is the same concept, if you will. The IT infrastructure is the foundation of an enterprise IT portfolio. It provides the capability for the services and sharing. It basically ensures that the services that are required by the organization are available and running at all times, or prescribed times. And the way IT organizations do this is they use service level agreements, SLAs. They make sure that we're going to provide you with a 99.99% uptime, that our infrastructure is in such a state that we can do that the downtime will be minimal. And if there is minimal downtime, it will either be planned or it will be handled. That in a disaster recovery, we are able to recover at a certain time point objective or in our recovery time objective, that we can basically recover from an hour ago, and it will take us, or it'll take us 2 hours to recover from a certain point in time, say 4 hours ago. And so our risk is, say, 2 hours at that point. Basically, a lot of things are linked to industry infrastructure. So certain banking payments, airline reservations, our infrastructure might be connected to other networks. If we are, we need to make sure that there's a certain level, a standard there as well. What's the time frame that it takes to send these transactions? Do we have enough bandwidth? Do we have enough processing power? Shared characteristics differentiate an infrastructure from IT investments used by just one function. Company-wide networks will be different, and data warehouses might be different. EDI capabilities would be different. So we may have differences in the structural infrastructure to handle these things. It might not all be the same. I don't need the same processing power for every system. I may need more processing power for our claim system if I'm in an insurance company, or I may need more processing power for my order entry system in a retail situation. But I don't need that much processing power, and I don't need necessarily high volume transactions for, say, an HR system or a legal system.